Ionic and covalent bonds. We have done this a lot. And page 7 in your packet is where you're going to find the notes on how to do that the most accurately. But the reason that we keep doing this is we cannot move on to any more complex problems and or balance and interpret chemical equations until we properly understand what the compound is, whether it's ionic and covalent, and what properties those have. So it's really important. Notice at the top it says use your periodic table and notes to complete this assignment. Identify the element in each formula, categorize them as metals or nonmetals, determine the type of bond each compound has. So this first page, we're just determining ionic or covalent. So I'm going to do a few with you. So I noticed the first element is not a metal. So that means I have two nonmetals. If you have a metal, it will come in the first spot. So that is covalent. I have a metal here, sodium and chlorine, and that makes it an ionic bond. Here, I have carbon as my first element. That is a nonmetal. That means that both of my elements will be nonmetals. So I have carbon and hydrogen, and I do want you to write each element name out. That is covalent because I have two nonmetals. Aluminum is my first element. That is a metal. Oxygen is my next element. That is a nonmetal. Since I have aluminum and oxygen, that is ionic. Carbon, my first element, that's a nonmetal. So I'm going to write carbon right here. Bromine. Okay, carbon and bromine are my two elements. They're both nonmetals, so it is covalent. And most of these are just like that. Look at the first element. Decide whether it is a metal or a nonmetal. If it's a metal, you have an ionic compound. If it's like this one, hydrogen is on the left side of the periodic table, but it is not a metal. So hydrogen and sulfur are both nonmetals, and it is covalent. So do the rest of those on your own, and I'm going to flip to the next page to give those instructions. Okay, I wrote you a little cheat sheet at the top of this page. It says these are all ionic, metal, and a nonmetal. So in order to name our ionic compounds, we find the metal, the nonmetal, and put "ide." If we want the formula, we find the charge, cross them, you must show the work. So don't forget about this up here. So I see calcium and nitrogen. Positive ion means metal. We know our metals always form positive ions, and our nonmetal is our negative one. So calcium and nitrogen. Positive ion is calcium, and it is positive 2. You look at the top of the group. Nitrogen is negative 3. So when I write the name, I just put "ide" on the end, metal, nonmetal, "ide." Calcium nitride. And to find the formula, I put positive 2 and negative 3, and I swap them. Okay? Calcium gets the 3, nitrogen gets the 2. All right? Now, I am not going to take the ones that are transition metals as a grade, but I do want you to understand the Roman numeral tells you the charge of that element. The reason those need a Roman numeral is because we have variable charges in our transition metals. What that means is we don't have a set charge. So in group 2, it always forms a positive 2 ion. This one's showing a 4. So that means I have 10, which is SN, with a positive 4 charge, and chlorine with a negative 1 charge. So I would name that 10, 4, I put the Roman numeral there if I have it, chloride, and I would put the positive 4 above 10, the negative 1 above chlorine, and it would be SN. It's going to get a 1 from chlorine, and chlorine is going to get the 4. Copper, 2, and bromine. So I have copper, Cu, with a positive 2 charge. Bromine, I look on the periodic table and see it's got a negative 1 charge. So I write copper, 2, and I'm only doing this because it's a transition metal, bromide, positive 2, negative 1. When I swap them, Copper gets the 1, bromine gets the 2. Okay, let's do one where it's normal, and then you'll have all of yours, and you know how to do the ones with the Roman numerals. So we have barium and fluoride. Barium is Ba. It's in group 2, so it's got a positive 2 charge. Fluorine is in group 17, and it has a negative 1 charge. So we have barium, fluoride. Positive 2, negative 1. When I swap them, barium gets the 1, fluorine gets the 2. Now, there are a couple that are hard to read. We've got silver and sulfur down here. That one's pretty easy. Chromium 3 and nitrogen. So chromium 3 and nitrogen. And I am not sure about 15, so just cross 15 out. Okay, now, if you look on the back, these are all covalent, non-metal and non-metal. So we use prefixes, no charges. So I see 1 carbon. I can't put mono in the first spot, so I just put carbon. I have 1 oxygen. I use a prefix every single time on the second word, so it's monoxide. This one is CO2. I'm not sure if you can see that too, but be sure it's there. This is carbon. Can't put mono in the first spot. There's 2 oxygens, so dioxide. So when you have a covalent compound, there will always be a prefix in front of the second element. There will always be a prefix in front of the first, as long as there's not just 1 in the first spot. Let's do this example. 2 nitrogens, I have dinitrogen, trioxide. All right. Let's do some examples on the right. Writing the chemical formulas. When it is covalent, there is no swapping of charges because they share electrons. They don't transfer. So nothing to write here. I'm just looking for the prefixes. So here I would have 1 carbon, 4 fluorines, 1 silicone, 2 oxygens, dinitrogen trisulfide, phosphorus monoxide is just PO. So keep going. Oh, I'm sorry, not monoxide. It's mononitride. So I'm just going to write PN, 1 of each. And you can go ahead and complete the rest of those. And that will be it for today.